Right. I think we should be live. I'm going to wait just a few seconds and make sure we come up on YouTube, and we should be good to go. And as always, with anybody watching, if you want to let us know in the comments that you can hear us and see us, that's always great. And then also, it's always cool to hear, where people are watching from, or if you want to put a little bit about your background, feel free to share that in the chat as well. One of my favorite things about doing live events is being able to see who we're talking to sometimes, or staying connected afterwards, which if you want to stay connected afterwards, there's also a link to a Slack channel in the description. But I'm going to go ahead and get going because we are live. So my name is Sage Elliott. I'll be the host today for the Robust and Responsible AI event. If you've never been here before or seen our content, we're a community of AI and machine learning practitioners, researchers, designers, and much more. Really, anyone working in the field of ML. You can think of this event kind of as a live podcast. We'll be interviewing our guest, and we're going to start with a specific topic today that's AutoML, and then we should have time for potentially questions at the end if you want to throw it in the chat, if there's some good ones, and if we still have some time, we'll try to get to them. But you can also stay connected and ask those questions later in the Slack as well. And if you want to come on for an event, if you have a topic in mind or anything you want to talk about, also feel free to reach out to me because I love having guests on. Today, we have our guest, Doris, with us to talk about if the world is ready for AutoML. And after we talk about AutoML, I think we're going to talk about how you can improve your machine learning engineering workflow with a really cool tool that Doris knows a lot about. And before we get going in the AutoML subject, Doris, could you introduce yourself and tell us a bit about your background?
Absolutely. Thank you so much for having me on the show, Sage. Super excited to be speaking about AutoML today. So my name is Doris. I've been working in the ML ops industry since before that was even a term yet. So that was my first job out of college. I was what we now would call an ML engineer. Back then, it was just, I had to make sure everybody heard it was software engineer who did machine learning. Right, like my team had over 30 ML PhDs, super excited to be a part of that. And it turned out my entire job was just actually data plumbing. Other people got to do the science, but there was a lot of engineering concerns after the fact to, create pipelines, put things into production, monitor models, and there's a whole workflow around that. So that was my introduction to ML ops, and that's where I started thinking that there are a lot of opportunities in this workflow for automation, for more robust tooling. And that's what inspired me to go on to get my PhD in computer science at UC Berkeley. My thesis was focused very heavily on developing machine learning systems with an eye for developer experience. That means it wasn't so much about we're running things faster, but rather how do we enable people to work on machine learning? How do we enable people to iterate faster, bring things into production in a much more seamless way? And I am continuing on that mission at Linea, which is a company that I founded after graduation. And our mission at Linea, again, is about being able to empower teams to deliver actionable insights faster, more efficiently, and in a more robust way.
That's awesome. I love the story too of like getting into the field, and then it's a lot of pipeline building or plumbing or whatever the term is, right? Because like a lot of people first getting into machine learning are excited to go build a model, but then if you're trying to get it in production, actually do something with it, turns out there's a lot more to it. And it kind of sounds like, I'm sure we'll get more into this a little bit later, but it sounds like I don't know if you really enjoyed working in that area, but it sounds like you've come back to it to at least improve it a lot for everyone.
Yeah, no, I think it's actually a really cool area in that it combines so many different disciplines of computer science. You're working on machine learning, but really you're also working on systems, databases, HCI, human computing interaction. All of these disciplines culminate into, the toolings that we see in ML ops.
Yeah, I think ML ops in general is a really interesting field right now because, like, if you've done machine learning, you've trained a lot of models. I don't want to say it gets boring, but it kind of feels easy sometimes to train a model, depending on what the task is, obviously. But yeah, there's just so many more pieces that allow you to deploy it and actually, like, put it out into the world and have it do something useful is kind of how I think about it.
Absolutely.
So I know the topic we were going to start discussing today is AutoML and if the world is ready for it. But first, before we get into if the world is ready for it, at a high level, for those who don't know, could you maybe explain what AutoML is?
Sure. Yeah. So AutoML is short for automated machine learning. And the goal is to automate some parts of model building. And the eventual goal is to really democratize data science and machine learning by making it a lot more accessible for people who don't have formal training in machine learning to be able to develop models, to be able to apply machine learning data science in a meaningful way in their own domain, their own applications. AutoML was originally introduced to automate just model hyperparameter tuning, right? So as you alluded to earlier, Sage, that there is a lot of kind of repetitive tasks in modeling, in model development. But over time, AutoML has evolved beyond that to include also other pieces of the pipeline, like feature engineering, data cleaning, model interpretability, and model deployment, right? So again, the ultimate goal is to be able to enable a lot more users to be able to use machine learning in a meaningful way.
Yeah, that's like it's kind of the next step of like you'll see a lot of not just big cloud companies, but people have like pre-trained models that you can kind of take out of the box and use. And AutoML is kind of the next step of allowing someone who maybe isn't a learning practitioner. Machine learning practitioners could also use it. But one thing I see AutoML pushed a lot for is you don't have to be a machine learning engineer, but if you can give a data set to an AutoML program, it can try to train a model using that data and then allow you to use a custom model versus just a pre-trained one.
Yeah, that's the hope.
So I know you've done a lot of research on AutoML, and it sounds amazing. I could just take all this data and give it over to a program, and it should build a great model for me. But what are some of the kind of maybe the downsides or precautions that maybe people don't think about when they want to use an AutoML system?
Yeah, that's a fantastic question. And I think that's something that's really top of mind for AutoML tool developers for sure. There's a lot of opinions out there on this matter, both from AutoML users and tool developers. Me being an academic or reform academic now, I wanted to really approach this problem in a much more rigorous way to answer this question with more evidence, with more rigor that goes into analyzing, how people are feeling about it, right? So what we did was me and my colleagues at UC Berkeley, we went out and interviewed 16 practitioners who self-identified as AutoML users, and we conducted semi-structured interviews with them. For those of you who are not familiar with that term, what that means is we wrote a script to follow for each of these interviews so we can have consistency across interviews. But at the same time, depending on the answers to the open-ended questions, we might ask follow-up questions that are unplanned in order to drill into more interesting insights. Right. So our participants came from pretty diverse backgrounds in terms of industry, job titles, organization size, and other geographic location and other demographics attributes. So after we've done the interviews, we studied the notes as a group. So there were 3 of us who were poring over all the nodes, trying to analyze, extract insights and trends. There was a lot of back and forth until we reached consensus on these are the findings that are really salient coming out of these interviews. The study itself was published at CHI 2021. CHI is a top-tier conference in human-computer interaction. Right. So back to your question, Sage. So the participants reported both benefits and deficiencies of AutoML. And for the downsides or deficiencies, I really want to highlight that what they have identified are more problems with the existing tools that we have. They're not really, something that's fundamentally wrong with AutoML itself.
Right.
So the 4 major limitations that our users, our interviewees identified were, the first one is lack of comprehensive end-to-end support. A lot of the tools are still very much stuck on AutoML is only for hyperparameter tuning. And in order for people to be able to use that tool, they have to transform their data into a specific format that the AutoML tool understands. And then whatever gets produced then has to be transformed into something else that downstream consumers can use. So there's kind of this ironic, it's kind of ironic that AutoML is supposed to save you work, but at the same time is requiring more work to be able to use it in the first place. So that's one major downside. And another one is AutoML can be extremely compute intensive, right? Think of how much compute goes into training a single model. AutoML allows you to train a lot more models in a short period of time. And that can cause very major system instabilities because you're kind of bombarding the system with a lot more compute, a lot more data, and you're not always 100% sure on the characteristics of the workloads. And there's also concerns around carbon footprint. Because it's so easy to push a button and spin up hundreds of machines to start training models, there's real concerns around the efficiency and just the sheer amount of compute that goes into running AutoML systems. The third limitation that we've heard users identify is lack of customizability. Users wanted more control anywhere between, for computation resource allocation, back to the point about this is using way too much compute. Is there a way for me to kind of say, I want to put a threshold on how much I'm going to use? And there's also desires to customize procedures like data cleaning, model search, and model interpretability techniques. And this point is really interesting because it presents a tricky balance between customizability, but also cognitive overload that leads to analysis paralysis. When you have too many knobs, then the automation aspect kind of gets lost in all of those knobs and buttons.
Right. You've just changed the UI kind of.
Yeah, exactly. Yeah, and the last piece, I think this is probably the most commonly cited problem by folks familiar with AutoML, which is lack of transparency and interpretability, right? So the concern here is kind of twofold. The first one is that users want more visibility into the process itself. I want to know how much compute has been used, what's the progress on the current model trained, how much more is going to go into AutoML, right? So that in itself is something that people want more visibility into. And there are a lot of tools out there that are more binary in that regard. We started it, we're done. It's a little harder for users to have clear expectations on how much that process is going to cost them, how long that's going to take, right? And then the second piece is, of course, being able to trust the models produced, right? As humans, as very curious creatures, we really need to do a lot of tinkering to really feel like we understand something, we have agency in the creation of it. And also, as ML practitioners, we feel a strong personal responsibility for the behavior of the models produced. So that also means that when somebody asks, why is this model behaving this way? It's not acceptable to say, well, this black box and this one thing gave me this model, and it said it had the highest accuracy of any of the models that it tried. So
Right.
these are kind of the major downsides that we observe. But of course, there are many, many upsides to AutoML as well.
Before we maybe circle back into like a couple interesting things of the downsides, do you have a couple of the upsides that you really like or that you want to point out? So we know that AutoML isn't all bad.
Yeah, I think there's a lot of kind of obvious ones, right? Like it's automating hyperparameter tuning. I don't have to do a lot of the repetitive stuff. It's lowering the barrier to people who can't even name models, right? Like I don't know what, for example, I don't know what CNN is or logistic regression, but I will be able to produce a model that does something, right? And the non-obvious ones were, one user reported that they felt like their AutoML system was their teacher. It was
Wow.
Yeah, it was like an educational experience for them to interact with the system, to see, these are different flavor models that are appropriate for this task. This is how they behave. What are the common types of hyperparameters being tuned? What are the ranges for it. So that one was a really, really interesting insight that we didn't expect at all going into this process.
I love that, because that's something that, yeah, like usually you have to spend a lot of time iterating on different models yourself and tuning these hyperparameters before you kind of gain that intuition and knowledge of like where to start. And I kind of really love the idea of learning by putting your data in an AutoML system, and it says like, well, these are probably the best models for this type of data, or these distributions, and here's how I would look at tuning the hyperparameters. That's really a cool story. Circling back on one of the downsides, one I didn't think about that's interesting to me is the carbon footprint side about. Obviously, you think about it training models and running things on GPUs and compute in general, but I guess that just didn't cross my mind about AutoML doing way more of that and what impact that could have on the future if everyone's using large AutoML systems.
Yeah, I think there's definitely, again, like I mentioned earlier, it's not inherently a problem with AutoML, is a limitation of our existing tooling.
Right.
So there are definitely opportunities for us to do things like, using pre-trained models, like you mentioned at the beginning stage, to cut down the number of experiments that we run. Being able to do other things like leveraging intermediate results that are commonly shared across different experiments as well. And this is actually another research project that I did during my PhD. So I think we're still early in that journey, and I think it's good that we're cognizant of this problem this early. But there's definitely concerns around, are we making it too easy for us to do bad things?
Right. I am glad that it's already a concern. That's great. Um, so we've talked a little bit about the downsides and obviously the really good upsides. Is there a future where you think AutoML could be like one of the best or main choices just in the ML industry as a whole? And if so, what do you think that kind of looks like?
Yeah, I love
Or could
questions
look like?
where I'm, basically asked to wildly predict the future.
Yeah, obviously no one's going to hold it you accountable if it happens or not.
Yeah, I think we are definitely a long ways from AutoML fulfilling its original goal of democratizing data science, right? For all the limitations that we just talked about. And the amount of compute, the amount of time and skills it takes to interpret the output, it's still very high barriers to entry. Even if there's something that you can push a button on, you still need somebody who has basic machine learning knowledge to be able to say that this model is something that's appropriately performing my task and safe to be put into production, right? And then transparency, interpretability, definitely major hurdles, especially now that we're a lot more cognizant of the real issues with machine learning and thinking more deeply about regulations around what are some data that can be used and what are some things that are simply very likely to introduce bias. Right. So all of these things considered, I think there is a lot of research that needs to go into transparency, interpretability, but also knowledge representation before we can really say that we can declare victory on AutoML. Anybody can pick it up and start doing something meaningful with it, right? And what I mean by knowledge representation is that right now we still require users to really understand their data to be able to say, these are relevant signals, this is the task I want to perform, and I'm going to be very explicit on how to use these labels to be able to train a model, right? But where we really want to get to is for somebody to say, I want to be able to, I don't know, maybe predict the next best drug that's going to help with COVID, for example, right? There's a pretty big gap between that level of, declaration and where we are right now, where this machine doesn't have any understanding of the spreadsheets that get fed into the model, right? The human still has to be very clear on the information that's present in the data that gets fed into machine learning. So all of that is to say it's extremely hard to tell when machine learning in the future is going to be the best choice. But I think there are a lot of things that we can do today to move towards that direction. And what we've heard from the user studies is that folks are really open to automation of the engineering chores in the ML model training process. And what I mean by that are things around, I mentioned very early on, right? Like the things that I did for my first job, building pipelines, be able to track lineage of like this data generated this model at this time, and also being able to kind of understand the interplay between different data sets, different models. So this notion of, I guess, AutoML ops is something that I see in our immediate future. AutoML itself, there's still a lot of work to do.
I love the term AutoML ops. I don't know if I've heard that before. It might be the first time several people are hearing it, and so I'll just say you heard it here first. Doris is predicting AutoML ops.
I think it's happening already. The future is now.
That's awesome. All right, so we've talked a bit about AutoML. It's really cool. I love hearing about your research. You have such an awesome background in this field, and you know so much about it. But I know we're um, already like 20 minutes in, so I'm really excited to hear about what you're working on at Linea AI. And you recently launched a project called LineaPy, and I'd love to hear more about it.
Yeah, so LineaPy is very much building upon what I just mentioned about AutoML ops is where it's at right now, right? There is so much opportunity for helping automate the engineering tasks. So data scientists, machine learning practitioners who are a lot more, they're more analytical creatures. They're not as keen or not as skilled in engineering, can reap the benefit of, good engineering practices and ability to deploy models into production without having to spend a lot of time learning those skills. So that's the main goal for LineaPy today. So said another way, today there is kind of a pretty big gap between development and production, right? So on the development side, we have tools like Jupyter notebooks, Python, all of these learning libraries that data scientists love using, but they have fundamental limitations in terms of scalability, stability, things that are concerns for the production side of things, right? Data engineers are very much worried about, once you put a model into production, how do I make sure that my model is constantly operating on the freshest data, right? How do I make sure that I can set up pipelines? How do I make sure that I can keep track of the lineage across things, right? So LineaPy is this way of bridging the gap between these two very different sides using literally 2 lines of code. I think that's like the super awesome piece about LineaPy is that we recognize that data scientists are already doing so much. They really don't need to have another tool thrown at them to do things in a very specific way. So what we're able to do and what's really special about the tool is that we are using program analysis to be able to automatically analyze the data scientist's code during development. So we can start capturing, analyzing, and then extracting very clean pipelines that the data engineer would be very happy to see from their data science partners to be able to start the process of productionization.
That's so cool. And only 2 lines of code.
Only
This is
2 lines
very
of code.
impressive.
So yeah, it took a lot of effort. It took a lot of innovation to be able to get to that point, right? And it also took like a different way of thinking about the problem. Like all the tools out there are more thinking, oh, let me just create another library that's relatively low code for data scientists to be able to incorporate into their workflow. And what we took the approach of, I like to call the un-DSL, right? Like, what if we don't have to make people write things in a different way to still be able to reap the benefit of the library? And the way we get to that point is by doing a lot of heavy lifting on understanding the language, understanding the program in the first place.
Very cool. I don't know if you have, I don't want to like an idea around or like a case study of like how much time that could save? Because it sounds like a lot, and I know I've looked at the tool a little bit, and it seems like there's a lot of time that could be saved by using it. Going from Jupyter Notebook to production. Do you happen to have any like use cases on that, or even just personal timing?
Yeah, we've actually heard quite a few people being really excited about LineaPy for a couple of reasons. One is, and we do have a user who's actually deployed LineaPy into production. So maybe let me talk about his use case. So he was basically a data engineer at this small fintech startup, and he was very dismayed by the fact that their analysts were writing to production tables in their Jupyter notebooks. And this was horrifying because he doesn't have visibility into what's going on. There's a lot of stability issues. So what he wanted to do was be able to take these notebooks, extract out the relevant business logic, and then turn them into pipelines that then get run on Airflow. So there is a very clean handoff between notebooks and what happens in an environment, an isolated environment that writes to production notebooks, right? So he was somebody we got connected with because we wanted to hire him. He said, "No, I'm good. I'm happy where I am." And then a couple months later, he actually reached out to me directly on LinkedIn saying, "Hey, are you guys still building that thing you told me about? I'm trying to do it myself, and I couldn't figure it out. Like there are so many limitations to this." So he started collaborating with us and ended up joining us part time to really iterate on this thing to help us build something that then that he got to use on a day-to-day basis. In terms of how much time we're saving, well, he spent over 40% of his time cleaning up notebooks, taking notebooks from his their analysts, and converting them into Airflow, right? And he's very fluent in Airflow. Now think about a data scientist who's picking up Airflow for the first time, who doesn't really think in terms of DAX and pipelines. It could take them weeks to months to be able to figure out how to create a pipeline out of their Jupyter notebooks.
Right. And I know like at some companies there's teams structured with roles that kind of do that almost full time sometimes, taking a notebook from a machine learning researcher or engineer and getting it ready for production.
Yeah, that's right. And a lot of teams, unfortunately, don't have that luxury. Hiring for
Right.
data engineers is extremely tough right now. What we're hearing is it takes about, on average, 18 months to be able to fill a headcount.
Wow.
Or you can pick up LineaPy today and see how far you can go down that path.
Yeah, and I know there's links in the description linking out to LineaPy, but is there any other places you want to shout out that would be a good place to get started? I know you actually have a workshop coming up tomorrow, and I'll share the link in the chat, and then I'll update the description after we stop talking with the link as well.
Yeah, so I think our GitHub and the workshop tomorrow would be the best places to start. For the workshop tomorrow, we are doing the API basics introduction. So you don't have to come with any background, just show up. We'll have something that you can play with right away, host a notebook that you can follow along. But at the same time, we're also going to walk through the basic concepts as well as the API step by step using a real example to help you imagine how you can apply LineaPy to your day-to-day work.
Awesome. Yeah, I love going to workshops. If people have time for it, I would definitely suggest checking it out as a good way to get started. How long is the workshop?
So it's only 30 minutes, and it's tomorrow at 11 a.m. Pacific time.
Perfect. And I shared the link in the YouTube live chat. So if you're watching live right now, you can go ahead and click on those and sign up. And then again, I will update the description. So if you're watching the recording of this, you'll be able to check out the description below and sign up in there as well.
Yeah, thanks so much, Sage. And if anybody has any questions for me or for the team, feel free to shout it out now or come to our workshop.
Yeah, because we're getting close on well, I guess we are at our 30 minutes. Do you need to go right this second?
I can stick around.
We'll stick around for a few more minutes. If anyone has any questions, put it in the YouTube chat and we should see it here. And if not, or while people are writing them out, do you have anything else you want to shout out, Doris?
As you can tell, I came to just talk about AutoML. Didn't really come with a lot of advertisement in mind. Just wanted, excited about the topic itself. Really excited about, our potential of helping bridge the gap between development and production in a very innovative way. Yeah.
I'm excited for it too. And I'm excited now to use the term AutoML ops because I feel like I should be using that for some of the stuff that I'm working on as well.
Yeah, I think maybe we should start like a AutoML ops consortium or something. I think there's a lot of tools who are, making effort in that direction. I think we're making a lot of really good progress there.
Let's do it. Yeah, anyone watching live, this is where the AutoML ops consortium idea was created. And I don't see any questions coming in right now, but there should be a link to the LineaPy Slack as well to the website. So if you have any questions about LineaPy, definitely stay connected with Doris in those places. Or you can also ask questions in the R2 Slack community, and I'll make sure that they go to the right place. And with that, I think we'll wrap up the stream. Thank you so much, Doris, for being on. It was awesome talking to you, and I'm really excited to see where LineaPy goes.
Thank you so much, Sage, for having me on. Had a blast answering your questions.
I will end the stream now. Thank you, everyone, for attending, and hopefully I'll talk to some of you later.